Salam sejahtera, my name is Kelvin Santana Anthony. My matrix number is 10DIT4B1155. I'll be presenting for cloud computing problem-based assessment, which I have chosen to task 1, that is risk mitigation and access management. For question A, that is propose 2 backup strategies to prevent permanent data loss and explain 2 important components of a disaster recovery plan. So the 2 backup strategies have been reflected to the scenario, which is automated backup and offsite backup. So to prevent a data loss, the organization should implement automated backups where data such as lecture recordings are saved regularly. It can be saved daily or weekly without any manual effort. So where this ensures that even if files are accidentally deleted, recent versions can be restored easily. In addition, where we have the offsite backup or cloud backup should be used to store a copies of data in a different location or region. Why we do save in a different location or region? Because to protecting against major failures like system crashes or cyber attacks. So for the disaster recovery, where it have the recovery time objective, which is RTO, and backup recovery procedures. So the recovery time objective defines how quickly the system must be restored after a failure to minimize disruption, for example, within 2 hours. Meanwhile, backup and recovery procedures provide clear steps and responsibilities for restoring data efficiently, ensuring the system can return to normal operation quickly. Next, for the question B, is list 3 immediate action you would take after discovering that student data has been leaked. After discovering a data leak, the first ever step is to report the incident immediately to management and relevant authorities, so a proper response can be coordinated quickly and legal requirements are met. Failing to report can worsen the situation and lead to serious legal consequences. Next, the organization must be notify affected users, such as students, by clearly explaining what data has been exposed. For example, their names, their IC numbers, and so on. So the potential risk like identify the theft or fraud and what actions they should take, such as changing passwords. So this reflect to the transparency is important to maintain trust and reduce their panic. The impact not informing the users can include the reputational damage and loss the confidence in the system. Finally, the organization should investigate and secure the system by identifying the root cause, such as what is happening, maybe because of the weak passwords or account sharing, which are key contributing factors to the breach. Immediate actions like resetting passwords, enforcing a stronger passwords policies, and enabling a MFA, which is multi-factor authentication, help to prevent further unauthorized access and reduce risk of a similar incidents in the future.
Hi, my name is Devendra and my metric number is 10DIT24F112. For this question, I will explain 3 access management features that can be implemented in cloud application to prevent unauthorized access, followed by 2 ways to train lecturers to use cloud applications securely. The first access management feature is multi-factor authentication, or MFA. MFA improves security by requiring users to provide more than one form of verification when logging in. For example, besides entering a password, the user may also need to enter a code sent to their phone or generated by an authentication app. This means that even if a hacker manages to steal a password, they still cannot easily access the account without the second verification step. Because of this, MFA is one of the most effective ways to reduce unauthorized access. The second feature is role-based access control, or RBAC. RBAC means users are only given access to the information and functions that are related to their role. For example, a lecturer may be allowed to upload notes, manages assignments, and view students' submissions, while students may only be allowed to access learning materials and submit their work. Administrative functions such as managing system settings or sensitive records would only be available to authorized staff. This reduces the risk of accidental misuse or unauthorized access because each user can only perform tasks that are relevant to their responsibilities. The third feature is single sign-on or SSO. SSO allows users to log in once using one trusted account, such as a university email account, and then access multiple cloud applications without needing to log in repeatedly. This improves both security and convenience. It reduces the number of passwords lecturers need to remember, which lowers the chance of weak passwords or password reuse. It also makes account management easier for the institution because access can be controlled centrally. Next, I will explain two examples of training that can help lecturers use cloud applications securely. The first training example is a password security and MFA workshop. In this training, lecturers can be taught how to create strong passwords, avoid common password mistakes, and enable MFA on their cloud accounts. This is important because many security breaches happen due to weak or reused passwords. By teaching lecturers proper login security practices, the institution can reduce the chances of unauthorized access. The second training example is phishing awareness training. In this type of training, lecturers learn how to identify suspicious email, fake login pages, and scam messages that attempt to steal account details. Practical examples of simulated phishing emails can be used so lecturers can recognize warning signs more easily in real situations. This is very important because phishing attacks are one of the most common ways attackers gain access to cloud systems. For this question, I will explain how cloud load balancing can prevent a website from crashing and then discuss three benefits of load balancing for an e-learning platform. Cloud load balancing helps prevent a website from crashing by distributing incoming traffic across multiple servers instead of sending all users' requests to only one server. In a cloud environment, many users may access the website at the same time, especially during busy periods such as online exams, assignment submission deadlines, or when lecturers upload course materials. If all of these requests are handled by a single server, that server can become overloaded, slow down, or even crash. Load balancing solves this problem by sharing the workload among several servers, so no single server carries too much traffic. For example, if hundreds or even thousands of students log into the e-learning platform at the same time, the load balancer will automatically spread these requests evenly across available servers. This keeps the system stable and reduces the risk of failure. In addition, if one server stops working, the load balancer can redirect traffic to other healthy servers. This helps maintain continuous service and ensures that users can still access the platform. Now I will explain three benefits of load balancing for an e-learning platform. The first benefit is high availability. This means the platform remains accessible even when there is a large number of users or when one server fails. For an e-learning system, high availability is very important because students and lecturers need to access learning materials, assignments, and online classes at any time without interruption. The second benefit is reduced downtime. Bec- Because traffic can be automatically redirected to other working servers, the system can continue operating even if one part of the infrastructure experiences problem. This reduces service interruption and ensures that important academic activities are not affected. The third benefit is a better user experience. When traffic is balanced properly, the website can respond faster and perform more smoothly. Students can open notes, watch lecture videos, and submit assignments without long delays, while lecturers can upload teaching materials more efficiently. This creates a more reliable and user-friendly learning environment.
Jin Zihuai, and matrix number is 1139. Today I would like to present the part 2, question B and question C. So first let's talk about the question B. Describe how cloud caching can help video load faster and give example for each. So first, cloud caching will store frequently used data temporarily in a cache server. With the cache, the student can load video faster from cache instead of the main server, so this can reduce the delay and improve the performance. Example, the lecture video and the lecture slide of the PDF notes should be saved in the cache server because many students will watch the same recording and frequently download it. Okay, next let's know about the difference between scale up, scale out, scale down, and scale in. So first, scale out it will add more servers to share the workload, and the scale in it will remove the extra server when the traffic is low. And next, for the scale up, it will increase the server power like the CPU or RAM, and for the scale down, it will reduce the server power when not needed. So what situation we will use scale up is like as we during the exam week or the peak hour, many students want to access the system, so we need to add more servers to prevent the website crash. Next, during semester break or holiday, there's only the few users, so we remove the extra server to save cost, and that's called scale in. Next, scale up. We upgrade the server RAM during the exam, so the system will not crash and it can handle heavier processing. Last, the scale down. At the late night, we reduce the server size since there's only a fewer students online. Okay, that's all. Thank you.